All right, number 19, you got the word problem starting here from the top of the tower. The angle of depression to a rock on the ground is 54 degrees. So I'm going to draw, like a vertical thing here for the tower. I don't know, something kind of like that right there. And then there's, I guess, a rock on the ground. So you can kind of draw this, I guess. And with all of these, really, you want to draw them as right triangles as best you can. And the thing with angle depression, if you draw your triangle like this here, angle depression is how many degrees down you are looking from up high. So the angle actually kind of goes outside of the shape right here, so you can put 54 like that. But since the line of sight right there and then the ground level, since those will be parallel, you can use the fact that alternate interior angles will be congruent right there, and you can put 54 degrees down there. Okay, and that's one way to do it as far as getting your angle set up. Another way you could also do it here is assume that this is a right angle here. And you can do 90 minus 54, and you would get, I guess, 36 degrees. And then you can use that 36 degree angle. But most of the times I just use the 54, so I don't have to do that extra step. Okay, the rock is 135 feet from the base of the tower, so that's that horizontal distance right there. The hard part of the word problems is just setting it up here correctly. So just make sure you're reading carefully. From the base of the tower means, the bottom of the tower. And then there's your rock right there. So that distance there has got to be 135. And they're asking how tall is the tower. So I'll put an X right there for the height of the tower. And then once you have it set up like this here, we can go ahead and set up our trig functions. We can go label opposite, adjacent, and the hypotenuse side right there. The trig function that uses O and A when we use SOHCAHTOA. I think I got that written down on a previous problem right there. O and A uses the one that starts with T. That's your tangent function. So that'll be tangent of 54 degrees and then equals X over 135. X is in the numerator, which means to solve for X, we need to multiply both sides. And you can still cross multiply and divide, however you want to think about it there. But that'll be 135 and then times tangent of 54 degrees. I got my calculator off the screen here today, so I'll type that in. Here, you know what? Let's go ahead and add it in. Hopefully we don't get an ad. Get an idea. Turn your play. Okay. So, yep, I'll type in, make sure your calculator is in degree mode. So you hit the mode button, find degree, highlight it, hit enter, and then second mode backs you out of that screen. And then, yep, we'll do 135, tangent, 54 degrees, and that comes out to about 185. What did they ask us around to? They didn't ask us around to anything, so I'll go 2 decimal places. So let's go 81. And that is in the unit of feet. Okay. So, yep, that is that right there. And that does, make sense right there. 54 degrees is bigger than the 36 degrees. So across from 54, you should have that higher height, that bigger distance, I guess, right there. So 185.1. Okay, next one here. You got a lighthouse 66 meters above the 66 meters above the sea level, spots a distress signal from a sailboat. The angle of depression is 12 degrees. So it's pretty much the same picture here. I got like some type of tower or lighthouse, I guess. I'm not really a good artist, but you can draw whatever you want here. Anyways, they spot a boat somewhere down here. Now they tell us the vertical distance is 66 feet, or what is that, meters actually. And here's your boat over here. If you want to draw yourself a boat, feel free. And we are going to now find out how far the sailboat is from the base of the lighthouse. So they're asking for that distance. And then kind of like the previous one, the angle of depression is 12 degrees, which in a way is kind of outside of the figure. But then by alternate interior angles, you can put it down there at the bottom right. Okay, and then we'll label O, A, and H, and that will use the tangent function again. That'll be this time tangent of 12 degrees, and then equals, this time it'll be 66 over x. The shortcut is x. If x is in the denominator, then you will cross multiply and divide eventually on this here. So I'll show the steps there just in case you missed it earlier. That's x times tangent of 12, and then it equals 66. And then you divide both sides by tangent to cancel out the tangent next to x. And that's 66 divided by tangent of 12 degrees. And then once again, make sure your calculator is in degree mode before you do this. Let's see if I can type it in here correctly. So that's roughly 14 point. Or hang on, did I? Oh, you know what? I didn't hit divide. 66 divided by tangent of 12. There we go. 310. Yeah, I was about to look at the answer, and what did I get? Like 14 or whatever before. That was going to be way too small for a realistic answer there. You know, so if you think about it, the way the triangle is drawn right here, this x distance must be way bigger than the 66 distance. And that's based off of the angles and everything. Okay, next one here. Top of a cliff is 85 meters above the ocean. From the top of the cliff, the angle of depression is 42 degrees, so it's another angle of depression. It's a common theme here. So let's say like your cliff is over here, kind of like that right there. It's 85 above. And the angle of depression is 42 degrees. And how far is the boat from the base of the cliff? So that's the bottom right there. So that'll be another tangent function because of the opposite and adjacent sides. That's tangent 42. That's 85 over x. If x is in the denominator, eventually when you cross multiply and divide, this will be 85 divided by tangent of 42. So let's see what we get here. 85 divided by tangent of 42. And that'll come out to about 94.4, I guess, 0. And what units are we in? We are in meters. So that'll be that. Okay. Next one here, you got a kite is flying at the end of the 170 meter string in a strong wind so that there's no slack in the string. The string makes a 55-degree angle of elevation with the ground, so I guess it's attached to the ground. How high above the ground is the kite? So let's say we got like a little spot here where the kite is tied to here on the ground, and then your kite's kind of going up like this. And they are asking for how high above the ground are you? So you can draw yourself, right triangle again. Now the angle of elevation is always from the horizontal and then up, so you can put 55 degrees like that. Then we can label the opposite, adjacent, and hypotenuse. What are they asking for here? How high above? So they're asking for that vertical distance there. I'll put x right there. The hypotenuse is actually 170 meters right there, because that's, the string right there. So that's a hypotenuse. So the trig function that uses O and H, if you go back to SOHCAHTOA, that's going to be the sine function. This will be sine of 55 degrees, and then equals x over 170. And then you can cross multiply and divide. That'll be x is 170, and then sine of 55 degrees. So this time you multiply, and that's because x is in the numerator. If x is in the numerator, typically that'll be multiplication. Okay, so that's about 139.26, and that was in meters again. So that's good. And, notice your hypotenuse of 170, that was longer than the 139, which does make sense in the context of the problem. Okay, Genghis Khan flew a kite over his enemy's camp to determine the distance between the soldiers and the enemy camp. He let out 800 meters of string, and the kite was flying at an angle of elevation of 61 degrees. How far away is his army from the enemy? Okay, so it's actually a pretty similar picture here. You got a kite that you're flying. It might be asking for a different thing, though. It is making an angle of, I didn't draw that perfect, but an angle of 61 degrees. Angle of elevation, so starting at the horizontal and up, and then 880 meters. And the kite was flying at that, and he's asking for how far away, which that to me seems like he's talking about the horizontal distance. So then you can label your O, A, and H, and the trig function that uses A and H is the cosine function. So that's cosine of 61 degrees and then equals x over 880. And then we can go cross multiply and divide. That's eventually calculator ready form 880 times cosine 61. And what does that come out to? Roughly 426.63. Okay, so that's that. Okay, next one here. Merlin's got a pet falcon. Arthur tethered to the ground with a 120-foot leash. If Arthur's angle of elevation is 62 degrees, how high above the ground is the falcon flying? And oh, you know what? And they do have rounding instructions. I just noticed that. Yep. Oh well. Anyways, y'all can get the rounding, I guess. Anyways, you got he's tethered to the ground, 120-foot leash. So you can put that right there. You got 62 degrees. And then, so pretty much the same picture again. And you are answering, where is it? How high is he? So you're going to put your X right there. So then you can go put O, A, the hypotenuse is always across from the right angle. So using the O and the H right there, that's the sine function. That'll be sine of 62 degrees and then equals X over 120. Okay, and then you can cross multiply that. Eventually calculator ready form is 120 and then sine of 62. So 120 sine 62 degrees. That's roughly 105. Let's actually round this here properly. Nearest hundredth is 2 decimal places. So we'll go back and round to 2 decimals right there, and that's good. And then new units. Let's see here, that's in feet. Okay. And then let me go ahead and fix these other ones. This 23 was the nearest meter, so that's a whole number right there. So I'm going to change that to the 427 on that one. 22 nearest tenth, that's 1 decimal, so I should have gone as 0.3. Nearest whole meter on 21 should have been 94 right there. Nearest tenth on this previous one here should have been 0.5. Nearest hundredth on the first one, we were good there on that. So here we go.